Mr. Clelland here from Clelland Maths. Today we're going to go through the whole of integration and higher maths, including trigonometry as well, and brackets. So we've got definite integrals, and everything on this page is everything we're going to go through. Let's just get started straight away. All the past paper questions will be included at the end. Okay, what is integration then? So previously we went how to differentiate terms. If we had f of x is x to the n, say, then f dash x would take the n to the front and take away 1 to the power. Here's some functions with derivatives. If the derivative is 9x squared, what was the function? Well, the function is x cubed to start with, because it's going to go to x squared, but that would be 3x squared, so I'm going to need a 3 on the end there. So 3x cubed is 9x squared. If the function was x to the minus 3 minus 8, then it must be, to start with, minus 2, because I'm going to take away 1 to the power. So I'm adding 1 to the power, really. And then a times by minus 2, but the answer is minus 8, so it must have been a 4 here. 4 times minus 2 is minus 8, x to the minus 3. And we're kind of work out, well, how do we go back from that then? Let's look at 5. If a function differentiated to 5, it must have started off with just 5x. And if a function started off with something and the answer was 0, it must have just been a number, so let's just pick any number, let's say 6. Now let's look at this pattern. If I add 1 to the power, I get to f of x, and then dividing by the new power gives me 9 divided by 3 is 3. If I add 1 to the power here, minus 3, that becomes minus 2. Minus 8 divided by minus 2 is 4. So it's something to do with the opposite of differentiation is integration. So I'm adding and dividing instead of times and taking away. The branch of calculus is the inverse of differentiation. It is also used to calculate areas, which we'll get to in a minute. And here is the actual formula for a standard function x to the n. Integrate, that's the symbol for integration. It's like an S, but longer. X to the n dx is x to the n plus 1, add 1 to the power, and then divide by the new power. But we've then got a plus c, and the plus c is because when you differentiate a number, you get 0. So if I go from an answer, I must have had a number to start with. It could have been any number though, so plus c. That represents the original function which we would have differentiated to give 0, the constant of integration. Now, later on when we're doing definite integrals, we will not have a c in because we're doing it between certain numbers. But if there's no numbers to put in, you need to add a c. That's the main point. Let's do some basic examples. So I've got 3 examples to start with. Example 1, integrate x squared dx. So step 1, add 1 to the power, that becomes cubed, and divide by the new power, then plus c. Now you can tidy that up if you want, just by writing it as a third, x cubed plus c, which can be quite handy to do when you have to put numbers in. Let's look at example 2. Integrate x to the minus 3 dx with respect to x onwards, because we're using x. So I add 1 to the power, x minus 3 becomes minus 2, divide by the new power, add c, and I do need to tidy that up because you can't have a negative in a bottom fraction. That's messy, it's not very good form. So we just write that as minus a half, or minus 1 over 2, x to the minus 2 plus c. And then if we wanted to leave that as a positive power, just in case we needed to, we could put the minus 2 on the bottom. X to the minus 2 becomes minus 1 over 2x squared plus c. But you don't have to do that for every example. I just thought I'll start doing that straight away so we get used to it. And then integrate, x to the 5 quarters dx. So we need to add 1 to the power. So 1 is 4 quarters, 5, 6, 7, 8, 9. So I get x to the 9 quarters. And then I need to divide by the new power, which is 9 quarters, plus c. Dividing by a fraction is the same as times and by its reciprocal. In other words, you write times and then you turn the fraction upside down. So I can write that equals x to the 9 over 4 times 4 ninths plus c. So that gives me, putting the 4 ninths in the front, x to the 9 over 4 plus c. And then just to go one step further, just for fun, let's change the 9 quarters as a power to a root. So powers become, fractions become roots when they're in powers. So that's 4 ninths And just to remind you how that works, x to the 9 just goes along from the right. I write the root sign, but it's the fourth root because the denominator is 4. So it's the fourth root of x to the 9 plus c, which might be handy in a non-calculator question if you're then having to sub in a number for the x. Look at some more examples. So example 4, integrate dr over r to the 4. Notice I've changed it from x to r. So dr means integrate with respect to r, so your answer is in terms of r. So r over 4, well, I can't do that to start with because I've got a fraction. I need to get it ready to integrate, just like I get ready to differentiate. I need all the powers on top of a fraction and in separate terms, at least for now I do. So that equals the integral of r to the 4 becomes r to the minus 4 dr. Add 1 to the power then, minus 4 becomes minus 3. Divide by the new power of minus 3, add c. So as a final answer, we get minus a third, just taking that out, r to the minus 3 plus c, or as a positive power, minus 1 over 3r cubed plus c. Example 5, find the integral of the fourth root of x to the 5. So again, fourth root, x to the 5, can't really do anything with that until I've got it as a power. So I change it to a power first. X to the 5 still stays as x to the 5, but it's the fourth root, so it's over 4. That's how you change that one. Add 1 to the power, so we now know that that's 5, 6, 7, 8, 9 quarters. Dividing by 9 quarters then. Adding c. Divided by 9 quarters is the same as timesing by 4 ninths, as we've already seen. So just flip it upside down to the 9 quarters plus c, and then putting it back in its original form just because we can. That's 4 ninths. Remember, we keep the x to the 9, we write a root, and it's fourth root, the fourth root of x to the 9 plus c. And we're done for that. Some more examples. Example 6, integrate 6u squared. So du, notice I've now just put a number in front, but that's okay. We can deal with this. You just add 1 to the power, so the 6 comes along for the right, u cubed, and divide by the new power, that's 3 plus c. And then I can do 6 divided by 3, which is 2. So that gives me 2u cubed plus c. Example 7, find the integral of 4x to the minus 3 halves. So the 4 comes along for the right, I've got x, I need to add 1 to minus 3 halves. Well, 1 half, so I need to add 2 halves, minus 3, minus 2, minus 1. So that's to the minus a half. Divide by the new power, that's minus a half again, plus c. Dividing, remember, is the same as timesing by the reciprocal. Flip it upside down, the fraction. So I've got 4 x to the minus a half times, I've got minus a half on the bottom, so that's minus 2 over 1, or minus 2 plus c. Times in the number parts together, 4 times 2 is 8, divided by 1 is still 8, so that gives me minus 8 x to the minus a half plus c. And then we'll usually leave it there, but let's just go one step further. You'll not get penalised in the exam for going further. We'll stop there if that's what we want to stop marking, it's fine. So one step further, minus 8 over x to the half plus c. One step further still, minus 8 x to the half is the square root of x. So you could have written that as well, plus c. But most of the time you'll get your mark at this point. Okay, a few more examples. Example 8. Hopefully you're following along okay so far and feeling confident. Find the integral of 7 over 2p squared dp. So be careful on this one. We need to make it positive. We need to make the power on top of the fraction. The 2 does not go along. So I've got 7 over 2, that stays where it is, p to the minus 2 dp. So then we can just integrate as normal. That equals 7 over 2 just stays where it is. P, add 1 to the power, minus 2 becomes minus 1. Divide the whole thing by the new power, plus c. A fraction divided by minus 1 is just, well, 1 goes into 7 over 2 times. So it's just minus 7 over 2, p to the minus 1 plus c. Or writing it as a positive power, minus 7 over 2 p to the 1. So just leave it as 2p plus c, and we're done there. Example 9. This time we've got a number of terms, but they're separated by a plus or a minus, so you just integrate them individually, as long as it's a term, then another term, then another term, and they're not all times together. So, first one, I've got 4x. It's minus 5 over 8, so I'm adding 8 over 8. That's 3/8. So it's to be 3/8. All divided by 3/8. That's step 1. Plus 3x, so that's power 1. So that becomes 3x squared divided by 2. 7, there's no x, so just bring an x in. 7x plus c. Tidy all that up. That's 4x to the 3x. And we need to times this one by 8 over 3. 3 over 2 just stays as 3 over 2x squared. Plus 7x plus c. 4 times 8 is 32. So simplified fractions are fine. 32 over 3. That is a simplified fraction. X to the 3/8 plus 3 over 2x squared plus 7x plus c. I'm not going to bother changing that to a root. I think I'll stop there on that one. Okay, 2 more on indefinite integrals. This time we've got a bracket to deal with, integral of t times t plus 3. So I need to get it ready to integrate by multiplying out the brackets. So that equals the integral of t squared plus 3t dt. Add 1 to the power, divide by the new power. So that's t cubed over 3 plus 3t squared over 2 plus c. So that gives me 1/3 t cubed. I prefer to write it as fractions to the side. 3 over 2t squared plus c. And we're done there. Integrate this. So we've got integral of 4m squared minus m plus 7 over the root of m to dm. So we can separate that into separate fractions, which you can do if you've got a bunch of terms on the top divided by a fraction. Do not be tempted to do it if it says something like the integral of 4m squared over m plus 1. It won't say that, don't worry. But if it did, you can't say that's 4m squared over m and 4m squared over 1. That's not true. It's only when you're doing it with a single term on the bottom. So I got 4m squared. Root m is m to the half minus m over m to the half plus 7 over m to the half. dm we'll say. So then we need to use our rules of indices to simplify each of these. So that's the integral of 4 m squared over m half. 2 minus a half, take away the powers, is 3/2. So that's m to the 3/2. That's a 1 there, so 1 minus a half is a half, so that's minus m to the half. 7 over m to the half is 7 over m to the minus a half, taking it up to the top. So quite a long one, this one. Add 1 to the power, divide by the new power. So we've got 4m, 3/2, 4/2, 5/2. So we're dividing by 5/2. Minus m, 1/2, 2/2, 3/2. Dividing by 3/2 then. Minus 7, plus 7, sorry, m minus a half goes to a half when you add 1. So I'm dividing that by a half plus c. Fraction workout is this one, isn't it? So we've got that. So then we need to fix all of that. So we've got 4m to the 5/2. And that's going to be times by 5. Dividing by 5/2 times by 2/5. Minus m to the 3/2. Dividing by 3/2 is times by 2/3. Plus 7m to the half. Dividing by a half is the same as times by 2 or 2 over 1 plus c. So just been very careful with my fraction work. 4 times 2 is 8. So that's 8 over 5m to the 5/2. Minus 2/3, m to the 3/2. 7 times 2 is 14, so plus 14m to the half, plus c. And then let's give our brains a workout even further. That would be the answer, but let's just go one step further and change this off to roots. So we've got 8 over 5, m to the 5 square root minus 2/3 m cubed square root plus 14 square root m plus c, and I'm done as far as I want to go there. Differential equations. So previously stated, integration is the reverse of differentiation. So that means that if we integrate the derivative of a function, we get back to the original function. So integrate dy by dx, which is what it says here, we get back to y. Or in other words, in function notation, if we integrate f dash x, we get back to f of x. But that gives us a general solution because when we differentiate a number, it disappears. So differentiate 5, you get 0, differentiate 6, you get 0. So it's going to give us f of x plus some constant c, or y plus some constant c. That's called the general solution. We can find a particular solution if we give some sort of limits, if we're given an x and a y. So let's have a look at some examples of differential equations. Example 1, the graph of y equals f of x passes through the point 3 minus 4. dy by dx equals x squared minus 5. Find y in terms of x. So if we're given dy by dx and we have to find y, we are integrating. So y equals the integral of x squared minus 5 dx. So y equals, add 1 to the power, divide by the new power. So x cubed, and that's a third. 5 is a constant, so that goes to 5x. So minus 5x. But then there's no limits on the integral, so it's plus c. And now we use our initial condition. We have got 3 minus 4. So that means that when x equals 3, y equals minus 4, so we can just substitute that in. So subbing that in, we get minus 4 equals 1/3 of 3 cubed, minus 5 times 3 plus c. So minus 4 equals, 1/3 of 3 cubed is 9, minus 15 plus c, minus 4 then equals 9 minus 15, which is minus 6 plus c. So c equals minus 4 plus the 6, which is 2. So now we just rewrite our equation. Y equals 1/3 x cubed minus 5x plus 2. And we're done there. Differential equations, example 2. A function is defined on a suitable domain such that f dash x is x squared plus 1 over x squared plus 2/3. Given that f of 1 equals 4, find f of x. So we're starting with f dash x, and we have to find f of x. So we are integrating. So we need to get it ready to integrate first. So let's start manipulating f dash x. F dash x is equal to x squared plus 1 over x squared is x to the minus 2 plus 2/3 is just a number. So f of x is equal to the integral of x squared plus x minus 2 plus 2/3 dx. So let's integrate that now. Add 1 to the power, divide by the new power. So that's x cubed, 1/3. X to the minus 2 becomes minus 1. So we're dividing by minus 1. I'll just write that there and we'll tidy it up later. Plus 2/3 of x plus some constant c. So that's f of x. Let's tidy that up then. F of x is 1/3 x cubed minus x to the minus 1 plus 2/3 of x plus c. So that is 1/3 x cubed minus 1 over x plus 2/3 of x plus c. And now let's see what our initial conditions are. It says f of 1 equals 4. F of 1 equals 4. So that means 1 is x. When x equals 1, y, or f of x, equals 4. So just subbing that in. 4 on the left equals 1/3, 1 cubed, minus 1 over 1, plus 2/3 of 1, plus c. So that means that 4 equals 1/3, minus 1, plus 2/3, plus c. Keeping our heads on with fractions, 1/3 plus 2/3 is 1, minus 1 plus c. So 1 minus 1 is 0, so 4 equals c. So now we can just rewrite our function as f of x is equal to 1/3 x cubed minus 1 over x plus 2 thirds x plus c, which is 4. And we're done there. Into definite integrals. So if f of x is the integral of f of x, big F, then we can define the integral of f of x between two numbers a and b as f of b minus f of a, where a and b are the limits of the integral, and b is obviously bigger than a. So in other words, as an example, if I had the integral of x dx between a and b, then that would give me x squared over 2 plus c between a and b. But then subbing in a and b, that would give me b squared over 2 plus c for the first one, minus a squared over 2 plus c for the second one. So now that gives me b squared over 2 plus c minus a squared over 2 minus c. You'll notice the c's cancel. So that just gives me b squared over 2 minus a squared over 2, which is the same as going back to here, not having a c at all. So that means that when we integrate definite integrals, when there's limits a and b, we just don't put a c in. We just put in the function that it becomes and substitute b in and substitute a in. Let's look at some specific examples. Definite integrals, example 1, integrate or find the integral of 5x squared dx between 1 and 3. So step 1, integrate. So we add 1 to the power, that becomes x cubed, and it's 5 over 3. Put little square brackets around it, and it's between 1 and 3. So that means you sub in 3, taking away sub in 1. So that's 5 thirds of 3 cubed minus 5 thirds of 1 cubed. So working out each of them separately, 3 threes is 9 times 3 is 27, divided by 3 is 9, times 5 is 45. You can use a calculator to help that. 1 cubed is 1, so minus 5 thirds. So 45 minus 5 thirds, again, use a calculator, or I prefer, keep it all mixed numbers because it makes it easier. 5 thirds is 1 and 2 thirds, so I'm taking away 1 and 2 thirds. So 45 minus 1 is 44, minus another 2 thirds is 43 and a third. Or you could do it with improper fractions. Okay, definite integrals example 2. Find the integral between 0 and 2 of x cubed plus 3x squared dx. So integrating first, add 1 to the power, that's a 4, divide by the power, that's a quarter. Plus add 1 to the power, that's a 3. 3 divided by 3 is 1, so that's that one done. And that's between 0 and 2. So we sub in 2. So that's 1 quarter, 2 to the 4, plus 2 cubed. Put that in big brackets, that's my first big 2 done, minus, and then we've got a quarter, 0, 4, plus 0 cubed. Now we can work out each bracket individually. So the first one, 2 to the power of 4 is 2 2 is 4, 2 is 8, times 2 is 16, divided by 4 is 4. 2 cubed is 8. So I'll get 4 plus 8 minus, well, 0 to the power of 4 is 0, 0 cubed is 0, so the whole of that is 0. So that just gives me 12, and we're done there. Definite integrals example 3. Find the integral between minus 4 and... Definite integrals example 3. Find the integral between minus 1 and 4 of 4 over x cubed dx. We need to get it ready to integrate first. So that equals the integral between minus 1 and 4 of 4 x to the minus 3 dx. Add 1 to the power and divide by the new power. So I'll start on my x. That becomes minus 2. 4 divided by minus 2 is also minus 2. So you get minus 2 x to the minus 2 between minus 1 and 4. Now, if this was a calculator question, you would like to substitute it in, but let's just assume it isn't. Not ready to substitute in. That gives me minus 2 over x squared between minus 1 and 4. Subbing that in, we've got minus 2 over 4 squared for the first one. Take away minus 2 over minus 1 squared. So lots of negatives, watch out for them. Minus 2 over 4 squared is minus 2 over 16. Take away minus 2 over minus 1 squared is 1. So that's minus an eighth. minus minus 2 is plus 2. 2 minus an eighth, well, we can just do that as fractions if you want for a change. That's 16 over 8. 16 minus 1 is 15 over 8. And we're done there. Definite integrals, example 4. Find the value of z so that the integral of find the value of z for which the integral between 1 and z of 1 plus 2x dx equals 4. So a little bit algebraic this one, but let's just try it. So we've got the integral between 1 and z of 1 plus 2x dx. So we can integrate that. 1 becomes x, and 2x becomes x squared. Add 1 to the power, that's squared, divide by the power, 2 divided by 2 is 1. So we've just got x plus x squared, and that's between 1 and z. So we're going to sub that in. That gives me z plus z squared for the first one, minus 1 plus 1 squared. But it tells us in the question that equals 4, so we just write equals 4 at the side. So that gives me z squared plus z for this bracket. 1 squared plus 1, that's 1 plus 1 is 2. Take away 2 equals 4. Oh, we've suddenly got a quadratic to solve, so make it equal to 0. So that gives me z squared plus z minus 6 equals 0. Factorising that, z and z, 3 and 2, plus 3 minus 2, so z equals 2 for the first bracket, and z equals minus 3. Check our limits. The limits were between 1 and z, so we can't have that because since z is greater than 1, so z equals 2 is our final answer. Use an integration to find the area under a curve. In general, we find the area enclosed by a curve in the x-axis between a and b as the integral between a and b of f of x dx, where you can imagine taking little slices of under your curve and it makes little rectangles. As that little distance here gets smaller, and it's just to add up all those little rectangles gives you the area. So you'll see that later if you ever do any further maths. But for now, just know that to integrate, we integrate between the limits, put them in, and it gives us the area under the curve and the x-axis. Example 1 says, the graph of f of x, y equals x squared minus 4x is shown below. Calculate the shaded area, and it's highlighted at point 4 and 5. So we just need to know that the shaded area is the integral between 4 and 5 of our curve, because it's above the x-axis, x squared minus 4x dx. So integrating that is normal, that's a third x cubed. 4x becomes minus 4x squared over 2, and that's between 4 and 5. So that's 1/3 x cubed minus 2x squared between 4 and 5. So then subbing our numbers in, that gives us 1/3 5 cubed minus 2 times 5 squared. There's our first one. Take away our second one, which is 1/3 times 4 cubed minus 2 times 4 squared. So 5 cubed is 125, so that's 125 over 3. 5 squared is 25, so that's minus 50. So there's our first one. Use a calculator if you need to. Take away 4 cubed, which is 64, over 3. 4 squared is 16 times 2 is 32. So we get that sum. So let's get rid of these brackets. That's 125 over 3 minus 50 minus 64 over 3 plus 32. 125 over 3 minus 64 over 3 is 61 over 3. Minus 50 plus 32 is minus 18. 61 over 3. 3 times 18 is 54. 54 over 3. 61 minus 54 then is 7 over 3 units squared, because it's some sort of area we just worked out. Now don't worry about all these sums that I'm doing after this point. In an exam, you'll get only 1 mark usually after the substitutions. You get your substitution right, it's just 1 extra mark. So if it's a non-calculator question, just try your best. If it's calculator, sub it in properly with a calculator. Area under our curve example 2, find the area enclosed by the graph minus x squared plus 5x minus 6 and the x-axis. So we've got our limits of 2 and 3. Now you either told them or you could find it out because that would be the roots. So you can make that equal to 0 to find them. So it's just the integral between 2 and 3 of minus x squared plus 5x minus 6 dx. So we integrate that, that's minus a third x cubed plus 5 over 2 x squared minus 6x, and that's going to be between 2 and 3. So we've got most of our marks already, we just need to substitute now. That gives us minus a third 3 cubed plus 5 over 2 3 squared minus 6 times 3. There's our first substitution. Take away minus a third 2 cubed plus 5 over 2 2 squared minus 6 times 2, and there's our second substitution. So we need to work on this. So let's just start working on that. 3 cubed is 27 divided by 3 is 9. So our first bracket becomes minus 9 for the first number. 3 squared is 9, 5s is 45, so plus 45 over 2. 6 3s is 18, so minus 18. Take away 2 cubed is 8, so minus 8 thirds. 2 squared is 4, divided by 2 is 2, times 5 is 10, so plus 10, 6 2s is minus 12. Tidying that up as much as I can. Minus 9 minus 18 is minus 27, plus 45 over 2. Take away minus 8 thirds. 10 minus 12 is minus 2. Again, use a calculator anytime you want. So let's just get rid of the brackets. Minus 27 plus 45 over 2 plus 8 thirds because of the minus minus plus 2 because of the minus minus. Doing the number bits, minus 27 plus 2 is minus 25. Doing the fraction bits, you can make a common denominator of 6. 3 times 45 is 135. 2 8s is 16. So that's minus 25, 135, 145, 151 over 6. 25 times 6 is 150, so that's minus 150 over 6 plus 151 over 6. 151 minus 150 is just 1. So, and likewise, it seems the answers are 6 square units. Again, don't worry if you can't do the number manipulation, it's really only worth 1 mark. Okay, let's look at the area between 2 curves now. If we've got one curve and another curve, if we work at the area for this one and then the area for that one, if we take away both of them, we'll be left with whatever's in the middle. So in other words, it's the area of the curve which is above minus the one which is below between the 2 points. So the one which is above is blue and the one which is below is green. So it's f of x minus g of x between a and b. And we just manipulate that so that we get a nice integral to start with and then solve as normal. Let's look at some examples. Area between curves, example 1. Calculate the shaded area enclosed by y equals 4x plus 16 and y equals 2x squared plus 10. So we can see on here that we have got the 2 curves, or the curve in a straight line, I suppose, and between these 2 points, this one's above and this one's below. So I'll just do this one minus this one between these 2 points. So it's my x's that I'm interested in. So it's minus 1 and 3. So let's write that up. The integral between minus 1 and 3 of 4x plus 16 minus the whole of 2x squared plus 10. Make sure you put brackets around it so that when you simplify it, you're getting your takeaways in the right place. So that gives me the integral between minus 1 and 3 of 4x plus 16. Let me just write it out longhand for us so we can really see this. Minus 2x squared minus 10 dx. And then we can just collect like terms. So that's the integral between minus 1 and 3. I'll write them in order of power. So I've got minus 2x squared. I've got plus 4x. And then 16 minus 10 is 6. So plus 6. And now I can just integrate as normal. Add 1 to the power, you get x cubed. Divide by the new power, so minus 2 over 3 or minus 2x cubed over 3.
plus 4x squared over 2 plus 6x. That's going to be between minus 1 and 3. We'll simplify and tidy up first then. So that gives me minus 2x cubed over 3 plus 2x squared plus 6x. Now this could be calculator or non-calculator, and don't get scared if it's calculator, because obviously you don't get as much marks after you've substituted in. You get a mark for your substitution and then usually another mark for your final answer. So let's get ahead and start working on this. That's minus 2 times 3 cubed over 3 plus 2 times 3 squared plus 6 times 3. That's our first big bracket. Take away minus 2 minus 1 cubed over 3 plus 2 times minus 1 squared plus 6 times minus 1. There's our next big bracket. So working on each individual term, that gives me the first term is 3 cubed, which is 27, divided by 3, which is 9, times 2 is 18. So I get minus 18 for the first term. 3 squared is 9, times 2 is 18, so I get plus 18. And then 6 threes is 18. So there is my first bracket, minus, now minus 1 cubed is minus 1, but if I times that by minus 2, I just get 2, so I get 2 thirds. Minus 1 squared is 1, times 2 is 2, so I get plus 2. 6 times minus 1 is minus 6. So there's my second bracket. Tidying that up, minus 18 plus 18 is 0, plus another 18 is 18, so my first bracket is just 18. Minus 2 thirds, take as long as you want, 2 minus 6 is minus 4, so I need to do that sum. So I'll just take everything out of brackets now, 18 minus 2 thirds, but minus minus makes plus, so plus 4. So that gives me 22 minus 2 thirds. 22 minus 2 thirds is 21 and 1 third units squared. And we're done there. Area between curves, example 2. Calculate a shaded area enclosed by the curves with equation 6 minus 3x squared and y equals minus 3 minus 2x squared. So let's have a look at the diagram. There is the two curves. So step 1, we need to find our upper, that's that one minus this one, and it's between these 2 points, but we don't know these points. We need to find the points of intersection first, or our limits. So points of intersection is when the equations are equal to each other. So our limits, which are the x coordinates of the point of intersection. So making them, since they're both y equals, I can just say 6 minus 3x squared equals minus 3 minus 2x squared. And then we can just solve that. It's a quadratic, so taking everything over the same side, we've got 6 minus 3x squared plus 3 plus 2x squared equals 0. 6 plus 3 is 9, minus 3x squared plus 2x squared is minus x squared, and that equals 0. Well, that's the difference of two squares, square, square. So we can just immediately factorise that and get 3 minus x, 3 plus x. So that means that for this bracket, 3 plus x equals 0. So x must be minus 3, and x must be 3 for this one, because 3 minus 3 is 0. So we get 3 minus 3, and then we can now go ahead and start to look at integration. So then we're going to do the integral between minus 3 and 3 of our upper curve, which is 6 minus 3x squared. Take away our lower curve, which is minus 3 minus 2x squared, dx. So that gives me the integral between minus 3 and 3. 6 minus 3x squared minus minus 3 is plus 3, minus minus 2 is plus 2x squared dx. So just watch for double minuses appearing. So that gives me the integral between minus 3 and 3. 6 plus 3 is 9, minus 3x squared plus 2x squared is minus x squared dx. So then we can go ahead and solve that. That gives me 9x minus x cubed over 3 between minus 3 and 3. So the first bracket, 9 times 3 minus 3 cubed over 3. Take away our second bracket, 9 times minus 3 minus 3 cubed over 3. Make sure when you're substituting in, you watch out for all the negatives appearing. 9 times 3 is 27. 3 cubed is 27, divided by 3 is 9. So the first bracket is just 27 minus 9. Take away the second bracket, 9 times minus 3 is minus 27. Minus 3 cubed is minus 27, divided by 3 is minus 9. But since that's minus 9 and it's take away, it's plus 9. So negatives appearing all over the place. 27 take away 9 is 2018. Minus 27 add 9 is minus 18. 18 minus 18 is 36 units squared. We're done there. Green curves, example 3. Two functions defined by x as a member of the real numbers as f of x is equal to x cubed minus 7x squared plus 8x, and g of x is 4x plus 4. And it says the graphs of f of x and g of x are shown below, find the shaded area. And I've given you the limits here, so I've got minus 1, 2 and 6. So it's the integral between f of x minus g of x between minus 1 and 2. But then we're going to have also the integral between g of x minus f of x between 2 and 6. That's just the combination of them. We're just adding the two answers together. So just doing them as separate things. So for first bit, we've got the integral between minus 1 and 2 of f of x minus g of x. So that's x cubed minus 7x squared plus 8x plus 16 minus 4x plus 4 dx. So we'll just do that one first and then do 2 to 6. So that gives me the integral between minus 1 and 2 of x cubed minus 7x squared, 8x minus 4x is 4x, and 16 minus 4 is 12 dx. So integrating that out, we get a quarter x to the 4 minus 7x cubed over 3 plus 4x squared over 2 plus 12x between minus 1 and 2. Tidying that up, you get a quarter x to the 4 minus 7x cubed over 3 plus 2x squared plus 12x. And that's between minus 1 and 2. So subbing in now, be very careful. 2 to the power of 4, 2 2 is 4 times 2 is 8 times 2 is 16, divided by, no, actually substitute in first, sorry. So we've got a quarter, 2 to the 4, minus 7, 2 cubed over 3, plus 2, 2 squares, plus 12 times 2. There's our first big bracket. Take away a quarter, minus 1 to the 4, minus 7 minus 1 cubed over 3, plus 2 minus 1 squareds, plus 12 minus 1s. Lots of work to do here. So 2 to the power of 4, 2 2s is 4 times 2 is 8 times 2 is 16. 16 divided by 4 is 4. So 4 for our first term here. 2 cubed is 8. 8 sevens is 56. So minus 56 over 3. 2 is 4 times 2 is 8. And 12 2s is 24. And that's take away. Minus 1 to the 4 is 1, so that's a quarter. Minus 1 cubed is minus 1, but times minus 7 is 7. So that's just plus 7 thirds. Minus 1 squared is 1, so that's plus 2. And 12 times minus 1 is minus 12. Okay, so let's deal with these. We've got the first bracket, whole number parts. 4 plus 8 is 12. 12 plus 24 is 36. So we get 36 minus 56 over 3 for our first bracket. Take away. We've got two fractions to add, so let's just add them. That's going to give me 3 on the top plus 4 sevens is 28 over 12. And then 2 minus 12 is minus 10. So that gives me 36 minus 56 over 3. 3 plus 28 is 31. So minus 31 over 12. And then minus 10 is plus 10. Almost there for the first one. 36 plus 10 is 46. And we've got two ways to deal with these. Change them back to mixed numbers. I'll keep them as fractions for now. I'll keep them as fractions. So if I times this one by 4 to make it out of 12, 4 times 50 is 200, 4 sixes is 24. We get 224 over 12 minus 31 over 12. So that's 46 minus 224, 225, 35, 45, 55. 255 over 12. So now you could do 46 times 12, which is a bit clunky, or you just change that to a mixed number. So that's 46. Counting in 12s, well, 12 tens is 120. So 12 20s is 240. 21s is going to be 240, 252. So that's minus 21s, that's 252, and 3 12s left over. So that's 46 minus 21, and 3 12s is a quarter. 46 minus 21 is 21. 31, 41, 2, 3, 4, 5, 6 is 25. But then minus a quarter is going to give me 24 and 3 quarters. So 24 and 3 quarters units squared. Now we're not done there. Remember that was just part 1. Go back to the question. We now need to do the integral between 2 and 6 of g of x minus f of x. So let's start working on that. So now we've got the integral between 2 and 6, of g of x minus f of x. So g of x was 4x plus 4 minus f of x, which was x cubed minus 7x squared plus 8x plus 16 dx. So that equals, the integral between 2 and 6. We've got 4x plus 4. So 4x minus 8x is minus 4x. And then 4 minus 16 is minus 12. And then we've got minus x cubed. And then plus 7x squared, because minus minus. So integrating all of that, minus 4x squared over 2. Minus 12x, minus x to the 4 over 4, plus 7x cubed over 3, between 2 and 6. So that is minus 2x squared minus 12x, plus x to the 4 over 4, plus 7x cubed over 3, between 2 and 6. So that equals minus 2x squared minus 12x minus x to the 4 over 4 plus 7x cubed over 3. Or you might write it in order of power if you prefer. Subbing in our numbers, we get minus 2 times 6 squared minus 12 times 6 minus 6 to the 4 over 4 plus 7 times 6 cubed over 3. Take away minus 2 times 2 squared, minus 12 times 2, minus 2 to the 4 over 4, plus 7 times 2 cubed over 3. So you can use a calculator for some of this if you want. For the first term, 6 is 36 times 2 is 72, so that's minus 72. Minus 12 times 6 is also minus 72. 6 to the 4 over 4, so 6 to the power of 4 is 1296. Let's just see 4 goes into that. 324. So 6 to the 4 over 4 is 324. 6 cubed over 3 times 7. Again, we can just use a calculator for that. 6 to the power of 3 divided by 3 times 7 is 504. So we get that for our first bracket. Minus 2 twos is 4 times 2 is 8, so minus 8. 12 twos is 24. 2 to the power of 4 over 4. 2 twos is 4 times 2 is 8 times 2 is 16. Divided by 4 is 4. And then 2 cubed times 7 over 3. 2 cubed is 8. 8 sevens is 56. So that's the first fraction, 56 over 3. So that equals, let's just do each bracket separately. Minus 72, take away 72, take away 324, plus 504 is 36 for our first bracket. Minus 8, minus 24 is 32, minus 32 minus 4 is minus 36, plus 56 over 3. So that gives me 36 plus 36 is 72, minus 56 over 3. So that equals 72 minus, well, 3 into 5 goes 1, with 2 left over. 3 8s is 24, 25, 26. So I need to do 72 minus 18 and 2/3. Again, since I've started to use a calculator, I'll just keep going. 72 minus 18 is 54. So it's 54. Take away 2/3 is 53 and 1/3. Units squared. Now remember when we started this question, we need to add both of these together because it's both areas together. So the two answers we got were 24 and 3/4 and 53 and 1/3. So total area (24 and 3/4) plus 53 and 1/3. That gives me 77 and 3/4 plus 1/3. I'll put a plus in there. So that's 77 plus 12, 9, 10, 11, 12, 13. 13 over 12. So that is 78 and 12 units squared. And we're finally done there. Okay, we're going to start looking at the area under the x-axis now, because so far we've done the area between two curves and the area between a curve and the x-axis, but it being above it. So I want you to consider this picture here. I've got g of x and I've got f of x. If I wanted to find the area enclosed between the two curves, we know that we do f of x because it's above it minus g of x because it's below it, right? But we can consider the axis basically as a curve. If we want to do this one here, we need to do the integral between this curve, this line, minus that one because that's below it. So this line, the x-axis equation is y equals 0. So it's y equals 0 minus whatever f of x is. So you just do upper minus lower, 0 minus f of x. In other words, just minus f of x would give you the integral between the x-axis and the curve below it. Example 1, area under the x-axis, calculate the shaded area below. So I've got a curve which is y equals x squared minus 4x, and we have to do it between 1 and 4. So that's going to be the integral between 1 and 4 of 0 minus x squared minus 4x. Or in other words, the negative of the function. So that's between 1 and 4 of minus x squared minus minus is plus 4x dx. And then this integration is normal. So we add 1 to the power, divide by the new power. So we've got minus x cubed over 3 plus 4x squared over 2, which is 2x squared. Between 1 and 4, so we'll just substitute our numbers in. That gives me minus 4 cubed over 3 plus 2 times 4 squared for the first bracket. Take away minus 1 cubed over 3 plus 2 times 1 squared. 4 cubed is 64, so that's minus 64 over 3. 4 squared is 16, 16 twos is 32. So there's our first bracket. Minus 1 cubed is 1, so times by a minus is minus 1/3. 2 times 1 squared is 2. So that gives me minus 64 over 3 plus 32 minus minus plus 1/3 minus 2. So that gives me minus 64 over 3 plus 1 is minus 63 over 3 plus 32 minus 2 is 30. Changing that to a number, 3 goes into 6 twice, 3 goes into 3 once, so it's minus 21 plus 30, which is equal to 30 minus 21, 9 units squared. And we're done there. Area under our x-axis, example 2, calculate the shaded area below, and it's y equals 3 minus 2x minus x squared. Now notice with this one, there is a bit above and a bit below. So it's the integral between minus 3 and 1 of just the function, take away nothing, because it's the x-axis, and then between 1 and 2 of minus the function, or 0 minus the function. So just like before when it was two curves, we'll just do it in two separate bits. So we've got, for the first bit, the integral between minus 3 and 1 of just 3 minus 2x minus x squared, because that's above the x-axis, dx. And then I'll just show you what we're going to be doing, but do it later. We're going to add on the integral between 1 and 2 of 0 minus 3 minus 2x minus x squared dx, because that's below the x-axis. So treating them separately, I'm just going to call this one A and this one B, and we're going to do A first, just so we can just keep it separately. We get 3x minus 2x squared over 2 is minus x squared, and then minus x cubed over 3, and that's going to be between minus 3 and 1. So working that out, we get 3 times 1 minus 1 squared minus 1 cubed over 3. Take away 3 times minus 3, minus 3 squared, minus 3 cubed over 3. So that gives me 3 times 1 is 3, 1 times 1 is 1, minus 1 cubed over 3 is minus a third, and then 3 times minus 3 is minus 9, minus 3 squared is 9, so let's take away 9. Minus 3 cubed over 3 is minus 27 over 3 is minus 9, but another minus outside is plus 9. So 3 minus 1 is 2, 2 minus a third is 1 and 2 thirds. Minus 9 plus 9 is just minus 9. Minus 9 is plus 9. So it's 10 and 2 thirds for the first integral, units squared. So then our second integral, let's just call it B. So there's B up there. So it's minus 3 plus 2x plus x squared. When you work it out, minus 3 plus 2x plus x squared, and that's between 1 and 2. So we integrate that to get minus 3x plus x squared plus x cubed over 3 between 1 and 2. That gives me minus 3 times 2 plus 2 squared plus 2 cubed over 3. First bracket, take away minus 3 times 1 plus 1 squared plus 1 cubed over 3. Minus 3 times 2 is 6, minus plus 4 plus 2 cubed is 8 over 3. Take away minus 3 plus 1 plus a third. Minus 6 plus 4 is minus 2 plus 8 thirds. Minus 3 plus 1 is minus 2, so minus is plus 2. And I've got a third, so minus a third. Minus 2 plus 2 is 0, so that's 8 thirds minus 1 thirds, which is 7 thirds, units squared. So now our total area is just our two answers added together, which was 10 and 2 thirds plus 7 thirds. That's 10 and 9 thirds. Nine thirds is 3, 10 plus 3, 13 units squared. And we're done there.
With the integrating functions of the form f of ax plus b. So we'll briefly realize how to differentiate functions of the form f of ax plus b, that's brackets. And if we've got ax plus b to the power n plus 1, then what we do when we're differentiating is we take the n plus 1 to the front, and we take 1 away from the power, And then we differentiate this bit and times by it. So that gives you a at n plus 1, ax plus b to the n. So if we wanted to go backwards, we would do the opposite, but there's a little thing you need to watch out for. So we would add 1 to the power, we would divide by the new power, but because with differentiation, with times by the derivative, the opposite of times and by this is divided by this. So we still differentiate this and divide by it, and it just goes under with the n plus 1, and then you would have plus c. Let's look at some examples like that so you can see exactly what's going on. So integration of brackets, example 1, find the integral of x plus 6 to the 4. So step 1, I keep my x plus 6 where it is, my inside function. I add 1 to the power. Immediately divide by the new power, which is 5. And then times by the derivative of x plus 6. In other words, the number in front of x is going to be 1. So that's 1. And then I've got plus c. So this simple example just simplifies to x plus 6 to the power of 5. So this simple example just simplifies to x plus 6 to the power of 5 all over 5 plus some constant c. And we're done there. Integration of brackets, example 2, integrate 5x plus 2 squared. So again, that gives me 5x plus 2, add 1 to the power, divide by the new power, and then we're really dividing by the derivative of 5x plus 2, but if you divide a fraction by a number, it's the same as just taking the fraction and putting it underneath here, so we can just put it there. So differentiate 5x plus 2, that's just 5, or the number in front of x, so it's 3 times 5 on the bottom, plus c, and that gives me 5x plus 2 cubed, all over 15, plus c, and we're done there. A further example of integration with brackets, example 3, integrate 1 over the cube root of the square root of 5x plus 2 dx. So we need to get that ready to integrate, so that's the integral of 1 over 5x plus 2 all in brackets. It's the cube root of 5x plus 2 to the half. So it's the cube root of 5x plus 2, so that's 1/3 dx. So that equals the integral of, take it to no fraction, 5x plus 2 to the minus 1/3 dx. And now I'm ready to integrate. So add 1 to the power and divide by the new power. So I've got 5x plus 2. Adding 1 to minus 1/3 is 2/3. I need to divide then by 2/3. But that needs to be times by the derivative of this on the bottom, so 5. So we need to tidy all that up, and we've still got a plus c. So tidying all that up, let's do it in stages. We've got 5x plus 2 to the 2/3, all over 5 times 2 is 10/3 plus c. So we've now got something divided by a fraction, so we can times and flip, times by the reciprocal. So finally, that will give us 5x plus 2 to the 2/3 times 3/10 plus c. So that equals 3/10 of 5x plus 2 to the 2/3 plus c. And then if it's an uncalculated question, you're looking to then substitute some numbers in, you would change that back to its roots. So let's just do that for the sake of completeness. 5x plus 2 to the 2/3, so that is a root then, and it's a cube root because it's over 3. 5x plus 2, and it's squared plus c. Now, as you'll see with these ones, we've just done a few simple examples, so it's all plus c. But from now on, you could be asked to integrate with brackets for any question to do with integration where you put in limits or find an area. So just be aware of that. You'll see that in the past paper questions down below. Integration of trigonometric functions. So we already know the derivatives of sine and cos. If f of x is sine x, then we know that f dash x is cos x. We've done that in differentiation. And similarly, if we know f of x is cos x, that differentiates to minus sine x. And therefore, we can go backwards from there. Cos, if you integrate cos x, you must get sine x. if you integrate minus sine x, you get cos x, which means if you integrate sine x, you must get minus cos x. And there with a plus c. Again, you don't need to know these if they're given in an exam paper, so just there for reference, but we'll use them now. Example 1, integration of a trigonometric function. Integrate 5 sine x plus 2 cos x dx. So we're just saying that sine goes to minus cos, so 5 just comes along for the ride, so minus 5 cos x is the first term, and cos just goes to sine, so 2 sine x, and then a plus c, and we're done there. Integration of trigonometric functions, example 2. Find the integral between 0 and pi over 4 of 4 cos x plus 2 sin x. Why pi over 4 not degrees? Because integration and differentiation for trig is already defined in radians. So be aware of that. So cos, remember, just goes to sine. So that just gives me 4 sin x. And sine goes to minus cos. So minus 2 cos x. And that is between 0 and pi over 4. Now, this could be a calculator question or non-calculator question, but I know pi over 4 is 45 degrees, which is the exact value, so it's probably non-calculator. But let's sub in. That gives me 4 sine pi over 4 minus 2 cos pi over 4. That's our first big bracket. Take away 4 sine 0 minus 2 cos 0. So working out each of these individually. If you don't know your exact values, here's a little triangle. 45 degrees, which is pi over 4, is an isosceles triangle. So it's just 1, 1, root 2. So the sine of pi over 4, sine of 45 is 1 over root 2. So that's just 4 times 1 over root 2 for the first thing. Cos of pi over 4 is also 1 over root 2. So that's minus 2 times 1 over root 2 for the second thing. And zeros, the sine of 0 is 0, so that's minus 0. The cos of 0 is 1, so that's minus 2 times 1. We'll tidying all that up. We've got 4 over root 2 minus 2 over root 2, just gives me 2 over root 2 for the first bracket. And 0 minus 2 is minus 2, so minus 2. So that's 2 over root 2 plus 2. So let's do a bit of revision on how to simplify something like that. We're adding 2 onto this, so let's make it the same denominator, 2 over root 2 plus, so just timesing this by root 2 over root 2, which is the same as times it by 1. That gives me 2 root 2 over root 2. So that's 2 plus 2 root 2 on the top over root 2 on the bottom. And you wouldn't really need to leave it as a rational denominator, but let's just assume you did. We'll times it by root 2 over root 2 just for the sake of it. Just to give you a bit of revision on surds, really. So that gives me 2 root 2 for the first term. 2 times 2 is 4, so plus 4 all over root 2 times root 2 is 2. Dividing everything by 2 then, that gives me root 2 plus 2 again. Okay, so we just looked at basic trigonometric functions for integration, but let's now look at it with the chain rule. So we previously learned how to differentiate trigonometric functions sin ax plus b and cos ax plus b. And we have to do this at high as well for integration. So similarly, when we differentiate sin ax plus b, we just did cos ax plus b and times by a, times by the number in front of x, or differentiate ax plus b in other words. So the opposite of that is integration. We integrate cos, that goes to sine, and instead of timesing by a, we divide by a, so it's 1 over a sine ax plus b plus c. Now in the exam you're told how to integrate cos ax, and it tells you it's 1 over a sine ax. So that plus b is just, doesn't make any difference to you, you just put it in. Similarly for cos, if you differentiate cos ax plus b, you get minus a sine ax plus b, which means if we integrate sine ax plus b, you get minus 1 over a cos ax plus b plus some c. Let's look at some examples. Example 1, for further integration of trig functions, integrate cos 4x. So cos goes to sine, so we just write sine of the whole function, 4x, and then divide by the derivative of 4x, which is 4, so that's 1/4 plus c. Then we're done there. Example 2, for further integration of trigonometric functions, integrate sine 4x plus 3 pi over 4. So sine goes to minus cos, whole function, 4x plus 3 pi over 4, plus the c, and we need to differentiate this function somehow. So 3 pi over 4 is just a number, so we can just ignore it. Differentiate 4x, you get 4, so it's divided by 4, or minus a quarter. So it's minus a quarter, cos 4x plus 3 pi over 4, plus c. Example 3 and further integration of trig. Find the area enclosed by the graph of y equals sine 3x plus pi over 6, the x-axis, and the lines x equals 0 and pi over 6. So I've got a picture of that here. There's the y-axis, and there's the line x equals 0. And there's the other line, which is pi over 6. So it's between, we want the integral between 0 and pi over 6 of this function, because the x-axis is below it. So we could just write that as an integral, the integral between 0 and pi over 6, sine 3x plus pi over 6 dx. So integrate that, and we get, goes to minus cos 3x plus pi over 6, and then we need to divide by minus a third. It is because 3x becomes divided by 3, and that's between 0 and pi over 6. So subbing the values in, we get minus a third cos 3 pi over 6 plus pi over 6 for the first one, minus a third cos 0 plus pi over 6, so just pi over 6. So that is minus a third cos 3 pi over 6 plus pi over 6 is 4 pi over 6. Simplify that to 2 pi over 3. Minus is plus a third, cos pi over 6. So let's just examine these angles. 2 pi over 3 is 180 divided by 3, 60 times 2 is 120. Now is that related to an exact value? Where we can check through a cast diagram. 120 would be here, which means 180 minus something is 120. It's related to 60. Pi over 6 is 30 degrees. So exact value triangles, we've got 60, we've got 30, we've got 2, 1, root 3. So we can say that the cos of 120 is related to the cos of 60. So the cos of 60 is a half, but 120 is in sine, so it's minus a half. And the cos of 30 is root 3 over 2. So we can now just sub in these values underneath here to get minus a third. Cos 2 pi over 3 is times minus a half, plus a third times root 3 over 2. That gives me a sixth. And then 1 times root 3 is root 3 over 6, or just 1 plus root 3 over 6 units squared. And we're done there. Okay, now just let's go and look at some past paper questions on integration, the whole past papers now, so you can get a good feel for how to do this topic and be confident. Integrating a polynomial. SQA Higher Maths 2019, paper 2, question 2. Integrate this polynomial. So we need to get it ready to integrate, just like with differentiation. So I'm going to change that to the integral of 6x to the half minus 4x to the minus 3 plus 5. And then we can integrate because we add 1 to the power and divide by the new power. So that gives me x to the 3 halves. Still times 6, but that's divided by 3 halves. We'll deal with that later. And then minus 4x to the minus 2. Minus 3 add 1 is minus 2, so divide by minus 2. Then plus 5x, and then remember to add your c. Okay, dividing by a fraction is the same as timing by its reciprocal, so I can just do 6 times 2 is 12, so that's 12 over 3. X to the 3 halves. 4 divided by 2 is 2, minus divided by a minus is a plus, so plus 2x to the minus 2, plus 5x, plus c. 12 divided by 3 is 4, so that's 4x to the 3 over 2, plus 2x to the minus 2, plus 5x, plus c. And you will get your final mark at that stage, but let's just assume you wanted to go further because you're going to use it in another question. this helps us revise indices. So we've got x to the 3 halves. So that's the same as x the square root, because of the 2, x cubed, plus 2, x to the minus 2 over x squared, plus 5x plus c. But you don't need to go that far for this question.
SQA Higher Maths 2023 Paper 1 Question 6. Integrate 2x to the power 5 minus 6 root x dx for x greater than or equal to 0. So integration without limits means there's going to be a plus c, but I need to get it ready to integrate. Root x becomes x to the half. So I'm going to integrate 2x to the 5 minus 6x to the half dx. So integrate, add 1 to the power, divide by the new power. So x to the 5 becomes x to the 6, and I've got 2 sixths, minus 6x, add 1 to a half, you get 3 halves. So I have to divide by 3 halves, and I've still got plus c. So dealing with the first one is easy. 2 sixths is a third, so we've got a third, x to the 6. Divided by a fraction, same as times and by its reciprocal. So times by it and then turn it upside down. So I've got minus 6 times 2 thirds, x to the 3 halves plus c. So that gives me 1 third of x to the 6. 6 2s are 12. 12 divided by 3 is 4. So minus 4 x to the 3 halves plus c for our final answer.
Differential Equations, SQA Higher Maths 2015, Paper 1, Question 15. The rate of change of a mug of coffee is given by this differential equation. It tells you some information. Express t in terms of t. What you need to realise is if you integrate a dt by dt, you just get t back. So we can just immediately say that t equals the integral of the right-hand side, 1 over 25 t minus k. And that will be with respect to t, because it's dt instead of dx as normal. So we'll just integrate and let's go. So we get 1 over 25 t squared, and then we times by a half because we divide by 2, and then minus k times t, but then we've also got plus c. So there is our integral. Let's just tidy that up. Dividing by a half, we get 1 over 50 t squared minus kt plus c. So there's our initial step, but then we need to eliminate that c, but luckily we're given some information. It says initially the temperature of the coffee is 100 degrees. 10 minutes later, the temperature has fallen to 82 degrees. Express t in terms of t. So first step, we know that initially, when t is 0, the temperature is 100. So we can say that when t equals 0, big T equals 100. Subbing all that in, we get 100 equals 0 minus 0 plus c. In other words, c equals 100. So we've now got t equals 1/50th of t squared minus kt plus 100. But we need to find this k, so we've got an extra bit of information. 10 minutes later, the temperature is 82. So in other words, when t equals 10, big T equals 82. Subbing that point in, we get 82 equals 1/50th of 10 squared minus k times 10 plus 100. So we just need to solve and get k back out. 82 equals 100 over 50 minus 10k plus 100. Just quickly running through this, you get 2 minus 10k plus 100. So you get 82 is 102 minus 10k. Moving the 10k over to this side to make it positive. That is 102 minus 82 is 20. So k is 20 over 10, which is 2. So our final answer is just t is equal to 1/50th of t squared minus 2t, because k is 2, then plus 100. And we're done there. Differential Equations SQA Higher Maths 2016, Paper 2, Question 9. For a function f defined in a domain suitable domain, f dash x is equal to this, and f of 9 is 40. Express f of x in terms of x. So again, it tells us that f dash x equals that. So if I integrate, I'm going to get f of x. So I just integrate the right. So I can just straight away say that f of x is the integral of 2x plus 1 over root x dx. Now I need to get that ready to integrate, sorry. So that is the integral of 2x plus 1 over x to the half dx. I can split that up into two separate fractions, 2x over x to the half plus 1 over x to the half dx. Integral of, so if that is a 1 power, 1 minus a half is just a half, so this simplifies to 2x to the half, and then that's plus x to the minus a half dx. So we can now integrate it, add 1 to the power, so we get x to the 3 halves. We've still got the 2, and we're going to divide by 3 halves in a minute. And then add 1 to the power of this, we get x to the half. Divide by the new power, so divide by a half, but then we've got our plus c. Remember, this is f of x. Tidying that up a little bit, f of x is equal to, dividing by a fraction means that this times by its reciprocal, so I do 2 times 2 is 4 over 3. So that's 4 thirds of x to the 3 halves, and 1 divided by a half is 2, so plus 2x to the half plus c. So there's our initial point, but then we need to find c because we're given some information. So we know that f of 9 equals 40. So in other words, that tells us that when x equals 9, f of x or y equals 40. We can just sub that in. So we get 40 for f of x equals 4 over 3. Now I'm going to change the x to the 3 halves to the square root of x cubed. So the square root of 9 cubed. And plus 2 times the square root of 9 plus c. Because this is actually, it's not a non-calculator, it's a calculator paper, but you can do it with a calculator really. So 40 equals 4 thirds. The square root of 9 is 3, so that gives me 3 cubed coming out. Plus 2 times 3 plus c. Now use a calculator anytime you want. 3 cubed is 27 divided by 3 is 9. 9 fours is 36. 2 threes is 6 plus c. So we get 40 is 42 plus c. And therefore c is equal to minus 2. So then we can express our f of x. F of x is equal to 4 thirds x to the 3 halves plus 2x to the half, and it was plus c, so minus 2. Or if you've already changed it all, f of x is equal to 4 thirds of the square root of x cubed plus 2 times the square root of x minus 2. Either of the options would be fine. For 1 question 10, given that dy by dx equals this, and y is 14 and x is 2, find y in terms of x. So dy by dx equals that, so if I integrate dy by dx, I get y back. So I can immediately say that y equals the integral of the left-hand side, 6x squared minus 3x plus 4 dx. And that's nice and easy. Want to do, add 1 to the power, divide by the new power, minus 3x squared over 2 plus 4x plus c. Always remember your c. Tidying that up, y equals 2x cubed minus 3 over 2x squared plus 4x plus c. But we're told that when y is 14, x is 2. So when y is 14, x equals 2. So we can sub it in to get 14 equals 2 times 2 cubed minus 3 over 2 times 2 squared plus 4 times 2 plus c. Now this was a non-calculator paper, so you just have to do this all manually. So 14 equals 2 2s are 4 times 2 is 8 times 2 is 16. 2 2s are 4 divided by 2 is 2 again. 2 3s is 6, so that's 6. 4 2s is 8, and then we get a c. 14 equals 16 minus 6 is 10, 10 add 8 is 18 plus c, and therefore c must equal minus 4. And we're done for c, so we just then say that y equals whatever we got before, 2x cubed minus 3 over 2x squared plus 4x, and then our c minus 4, and we're done there. Equations SQA Higher Maths 2019, paper 2, question 13. A function defined a set of real numbers. It is shown that the rate of change of f with respect to x is given by this equation. The graph of y equals f of x crosses the x-axis 7, 0. Express f of x in terms of x. This question, I suppose, is asking you about do you know what rate of change is? Well, rate of change means differentiation. So we know that f dash x equals 3x squared minus 16x plus 11. So that means that f of x is the integral of this. And we'll get to the second bit of information to get c in a minute. So integrating that, we get x cubed times 3 over 3 minus 16x squared over 2 plus 11x plus c. So there's our initial step. We can simplify that in a moment. But it tells us that the graph of y equals f of x crosses the x-axis at 7, 0. Well, 7 is x and 0 is y. So we can substitute 0 and 7 into our equation. So we've got f of x, tidying it up, equals x cubed minus 16 over 2 is 8x squared plus 11x plus c. So when x is 7, y is 0. When x equals 7, y, which equals f of x, equals 0. So subbing that in, we get 0 equals 7 cubed minus 8 times 7 squared plus 11 times 7 plus c. This was a calculator paper, so you could do all the sums in a calculator, but 7 cubed is 343. 7 squared is 49 times 8 is 392. 11 sevens is 77. And then we've got plus c, and 0 equals this. Tidying all that up, we get 0 equals 343 minus 392 plus 77 is 28 plus c, and therefore c must equal negative 28. We've got our c, so we'll just sub it back into the equation we just found above. So therefore f of x is equal to our x cubed minus our 8x squared plus 11x minus 28. And we're done there.
Question 6. A curve of equation y equals f of x is such that dy by dx is 1 minus 3 over x squared, where x is greater than 0, of course. Curve passes through point 36, express y in terms of x. So if we just integrate, then we'll get y equals the integral of 1 minus 3 x squared on the bottom, so x to the minus 2 dx. So we add 1 to the power and divide by the new power, so that means that y equals x minus 3 over minus 1, x to the minus 1, but then we've got plus c. So tidy that up, y equals x plus 3 over x plus c. So we're going to have to work out c, but we're given a point 3, 6. So we can just substitute that in. So at 3, 6, we've got that's our x and that's our y, remember. So 6 equals 3 plus 3 over 3 plus c. 6 equals 3 plus 1 plus c. 6 equals 4 plus c. So it's easy to see that c must be 2. So to answer the question, y equals x plus 3 over x plus 2.
SQA Higher Maths 2023, paper 2, question 12. A curve for which the y by the x equals 8x cubed plus 3 passes through minus 1, 3. Find y in terms of x, or differential equation. And integrate dy by dx to get y, but that's going to have plus c, so sum in the point. So y equals the integral of 8x cubed plus 3 dx. So y equals, add 1 to the power, divide by the new power, so 8 over 4 plus 3x plus c, or y equals 2x to the 4 plus 3x plus c at the point when x equals minus 1, y equals 3. So subbing that in, we'll get 3 equals 2 times minus 1 to the 4 plus 3 times minus 1 plus c. So 3 equals 2 minus 1 to the 4 is 1. 3 times minus 1 is minus 3 plus c. 3 is minus 1 plus c, so c equals 4. And therefore, we just rewrite our equation with the c replaced by the number 4. 2x to the 4 plus 3x plus 4. And we're done there. Mr. Clare here from Clare Maths. Today we're going to be looking at a paper 2015, paper 2, question 4 of the SQA Higher Maths exam paper. Let's jump straight in. Okay, this one was about a wall plaque made to commemorate the 150th anniversary of the publication of Alice in Wonderland. Okay, so the edges of a wall plaque are modelled by quadratic functions, and there's 1, 2, 3, 4, and it gives you 4 bullet point equations. So what makes this one difficult is it'll give you all these equations, all this information, but you just need to keep your head. So let's look at part A. Find the coordinate of the point of intersection of the graphs of y equals f of x and y equals g of x. So point of intersection means simultaneous equations. So the two ones I need are this one and this one. Since that would equal y and y, so I can just make both of these equal to each other. So to get 1 mark for part A, I'll just do here. I can just write a quarter x squared minus a half x plus 3 equals a quarter x squared minus 3 over 2x plus 5. And that will give you your first mark. Okay, now we need to solve that to get the x part. And it only asks for the x part, so that's good. Notice if you've got the same thing on both sides, they just automatically cancel. So immediately I can just get like a red pen or something and go, that's the same as that. Same sign and everything, so I can cancel them. I've got minus a half x, so I can add 3 halves x to both sides. And that will get rid of it on this side. So let's just do that and do it in stages. 3 halves take away 1 half is 2 halves, which is 1. So that just gives us x left on this side plus 3 equals 5. And then we can just solve that to find x. Take away 3, so x equals 2. As unlikely as it seems, our answer. Part B says the graphs of f of x and h of x intersect on the y-axis. The plaque has a vertical line of symmetry. Calculate the area of the wall plaque. You should know a power word for integration is area. So if it says area, you need to integrate and you need to find the two limits. So we've already got our first limit, it's 0. We need to know this one. Well, this one is going to be the same as this one, which you worked out in part A, where these two intersect, was 2. So that's just 2. So I need to do the integral of the upper f of x minus the lower h of x between 0 and 2. So making sure you copy it down properly, it's the integral between 0 and 2 of f of x, which is a quarter x squared minus a half x plus 3. Put that in brackets. Take away h of x, which is this one, 3/8 of x squared minus 9/4 of x plus 3 dx. So at that point, you may be wondering, well, how much marks do I get? Well, at that point, you get a mark for knowing to integrate, so using the integration sign, just that. Another mark for putting in the limits, 0 to 2, and then another mark for writing down the two curves taken away from each other. So 3 marks for literally doing no work. It's not bad, that. And then we need to integrate it, and you actually only get 1 further mark for the integration. So all the tidying up you're going to do now, you're not going to get any marks for, but you still need to do it to be able to integrate. So let's tidy this up. So that gives us the integral between 0 and 2. You've got a quarter x squared minus 3/8 x. So a quarter is 2/8. So being very careful, you've got 2/8 minus 3/8. You've got minus an 1/8 of x squared. Looking at the x parts, you've got minus a half minus minus becomes plus. So plus 9/4. Well, putting a half into quarters is 2/4. So you've got minus 2/4 plus 9/4 is 7/4. so plus 7/4 x. And then we've got our number parts, but they cancel. 3, take away 3 is nothing. So we get the integral of this between 0 and 2, and then we need to integrate it. So that gives us x cubed. Add 1 to the power and divide by the new power. So 3 times 8 I need to do, which is 24. And then plus x squared. I've got 7 still. But I need to divide by 2. So I've got 4 already on the bottom. So 4 times 2 is 8. And that's between 0 and 2. So that gives us another mark at that point. So let's move on and substitute our limits in. So we've got minus 2 cubed over 24 plus 7 times 2 squared over 8. Take away minus 0 cubed over 24 plus 7 times 0 squared over 8. Okay, so we get a mark for our substitution. And then we need to evaluate it to get another mark. So we could use a calculator at this point because it is a calculator paper, but I'll just go ahead and do it without. So we've got 2 2s are 4 times 2 is 8 over 24, so minus 8 over 24. And then the other number, 2 2s are 4, 4 7s is 28, so you get 28 over 8. And luckily, you've substituted 0 in here, so that is a big fat 0 for this. 0 cubed is 0, over that is still 0, 0 squared is 0, over that is still 0. So you just need to work out these fractions. So I can simplify the fractions. Well, actually, I'll add them first before I simplify because it'll be easier to see. So minus 8 over 24, and then we've got 28 over 8. 8 3s is 24, so times them by 3. I get 3 times 20, so we get 84. So now we can add them. 84 take away 8 is 76 over 24. Simplify that because you have to always have simplified answers. So I'll just divide through by 2 to get 35, 36, 37, 38 over 12. Divide them by 2 again to get 19 over 6. And 19 is a prime number, 6 doesn't go into it, so 19 over 6 is our final answer for another mark. And feel free to do that in any way you want to get 19 over 6, but that isn't the answer. You need to check your question, calculate the area of the wall plaque. Well, we have calculated the area from here to here. So all that bit, if I was to draw a line down here, but you can see it's symmetrical, it even tells you it's symmetrical. So the area of the wall plaque is double the area I just found out. So our final area, just to get our final 7th mark, the area, total, equals 19 over 6 times 2. 2 times 19 over 6, well, that's the same as 19 over 3. So 19 over 3 is our final answer for our final last mark. This has been Clelland Maths today. We've been looking at an integration question, quite a difficult one from 2015, paper 2. Take care, stay safe, and goodbye. Integrating the find area, SQA Higher Maths 2016, paper 2, question 3. Show that x plus 1 is a factor, and then solve the equation. So that's not integration at all, but we'll do it for the sake of completeness. Then part B says, the diagram below shows the graph of this equation. Write down the coordinates of point A and B, and then calculate the shaded area in the diagram. So we're going to have to do part A to get the coordinates anyway. So part A, show that something's a factor. We can use synthetic division. So for part 1, I'll set up my synthetic division nice and quickly. I've got 2 minus 9, 3 and 14. And we're trying to show that x plus 1 is a factor, so I can sub in minus 1. So I've got 2 minus 2 minus 9 is minus 11, times by minus 1 is 11, 11 and 3 is 14, times by minus 1 is minus 14, we get 0, and we'd need to write a little statement, the remainder equals 0, therefore x plus 1 is a factor of f of x. Part 2 of this says to solve the equation then, well, we've now got x plus 1 is a factor, and we've got what's left over, 2x squared minus 11x plus 14. So that equals 0. We should be able to factorise this, hopefully. We've got double brackets. It must be 2x and x. 7 and 2 make 14. So minus 2 times 2 is 4. And then 7 equals 11. So minus 4 minus 7 is minus 11. So we've got x equals minus 1, or x equals 7 over 2, or x equals 2. Part B, the graph cuts the x-axis at A, B, and C right down the corners of A and B. Well, we've just worked it out. Our smallest x is A, our next smallest is B. So in other words, A equals minus 1, 0, and B equals 2, 0, and C would be 7 over 2, 0 as well. Part 2 of B, calculate the shaded area. Well, that's integral between these two numbers of our original equation. There's our equation, so it's the shaded area is the integral between minus 1 and 2 of 2x cubed minus 9x squared plus 3x plus 14. So we integrate and solve. So that equals, add 1 to the power, x to the 4 over 4, minus 9x cubed over 3, plus 3x squared over 2, plus 14x, and that is between minus 1 and 2. We then get a mark for subbing in, so let's just sub in our numbers. So tidying this up, that's a half of 2 to the power of 4. 9 divided by 3 is 3, so that's minus 3 times 2 cubed, plus 3 over 2 times 2 squared, plus 14 times 2, so that's our first one, big brackets around it, minus our second one, so that's a half, minus 1 to the 4, minus 3, minus 1 cubed, plus 3 over 2, minus 1 squared, plus 14 times minus 1. And quite often after this point it gets a little bit messy, but you're getting another mark just for solving that. But if you can get this far, you're doing really well. So let's just try and get this really tidied up. Dealing with each one separately. 2 2s is 4 times 2 is 8 times 2 is 16. 16 divided by 2 is 8. So we get 8 for our first term. 2 2s is 4 times 2 is 8. 8 3s is 24. So our second term is minus 24. 2 2s is 4. 4 divided by 2 is 2 times 3 is 6. So we get 6. And then 14 times 2 is 28. So there's our first bracket. Minus. Minus 1 to the 4 is 1. Times a half is a half. Minus 1 cubed is minus 1, times minus 3 is plus 3. Minus 1 squared is 1, times 3 halves. And we've got minus 14 on the end. Now, you can use a calculator for most of the work on this. I would leave fractions as fractions, but none of this is going to end up being fractions anyway. That equals, using a calculator, tidying up our first bracket, we get 18. And our second bracket, we get minus 9. So it's minus 9. That equals a final answer of 27. So it's 27 as our shaded area, and we're done there. Fine area. XQA High Maths 2017 Paper 1 Question 10. Two curves with equation x cubed minus 4x squared plus 3x plus 1 and x squared minus 3x. Add 1, intersect in a diagram. Calculate the shaded area. To do shaded area between two curves, it's the upper curve minus the lower curve between the x's, which is 0 and 2. So I can immediately write down it is the integral between 0 and 2 of our upper curve minus our lower curve dx. So we can tidy that up before we integrate. 0 and 2, we've only got an x cubed term, and then our x squared, 4 minus 1 is minus 5x squared. Our x terms, 3x minus 3x is plus 6x. Watch your signs. And then 1 minus 1 is 0. So we get this integral to do. So that is x to the 4 over 4 minus 5x cubed over 3 plus 6x squared over 2 between 0 and 2. That's x to the 4 over 4 minus 5x cubed over 3 plus 3x squared between 0 and 2. So we can now substitute our numbers in. So that gives us 2 to the 4 over 4 minus 5 times 2 cubed over 3 plus 3 times 2 squared. There's our first bracket. Minus, and it should be clear that it's going to be 0, but just for the sake of completeness, 0 to 4 over 4 minus 5 times 0 cubed over 3 plus 3 times 0 squared. All that stuff separately is 0. So we're just left with our top bracket. 2 2s is 4 times 2 is 8 times 2 is 16. Divided by 4 is 4 for our first term. Second term, 2 cubed is 8. 8 5s is 40, so we get minus 40 over 3. And 2 squared is 4 times 3 is 12. Tidying that up, we get 16 minus 40 over 3. Non-calculator, easiest way to deal with that is mixed numbers, I would say, because 3 times 13 is 39, so minus 13 and a third. 16 minus 13 is 3, minus an extra third is 2 2/3. And we're done there. Part B says the line passing through the points of intersection of the curves has the equation y equals 1 minus x. What fraction of the shaded area lies below the line? So we need to work out what the integral is below the line and see what fraction of the whole that is. You should be able to guess what the answer should be just by looking at it, but you can't guess. You have to do it. So we're doing the integral of between 0 and 2. Our upper function is the line this time, so 1 minus x. Take away. The curve below the line is x squared minus 3x plus 1 dx. Alternatively, you could have done this minus a line and then with a fraction left over to make a complete whole. It's your choice. But I'm going to do it this way. So that gives me the integral between 0 and 2 of 1 minus 1 is 0. I've got minus x minus 3x, so that's 3x minus x is 2x. Then I've got minus x squared as well, so you get 2x minus x squared, a nice simple function to integrate. So that gives you 2x squared over 2 minus x cubed over 3 between 0 and 2. That gives you x squared minus x cubed over 3 between 0 and 2. So substituting 0 in, we get 2 squared, 2 in, so we get 2 squared minus 2 cubed over 3. Take away 0 squared minus 0 cubed over 3. That gives me 4 minus 8/3. That's 4 minus 2 2/3. That is 4 minus 2 is 2. Take away 2/3 is 1/3. So 1 1/3. But if you go back to our original question, the total area was 2 2/3. Remember, our total area was equal to 2 2/3. It should be obvious that that is a half. So therefore, a half of the area is below the line. And we're done there. Great to find the area. SK High Maths 2018, paper 2, question 1. Nice simple one here. The diagram shows this curve. Find the calculated shaded area. So it's the area between minus 1 and 3 of this minus x-axis. So just this. So it's the integral between minus 1 and 3 of 3 plus 2x minus x squared dx. So that gives me 3x plus add 1 to the power, divide by the new power, minus add 1 to the power, divide by the new power, between minus 1 and 3. Tidying that up, 3x plus x squared minus x cubed over 3, between minus 1 and 3. You've got most of the marks so far, we just need to sub in our numbers now. So we get 3 times 3 plus 3 squared minus 3 cubed over 3. Take away 3 times minus 1 plus minus 1 squared minus minus 1 cubed over 3. 3 3s is 9. 3 3s is 9 again. 3 cubed is 27 divided by 3 is also 9. So our first bracket becomes this. Minus our second bracket, minus 3. Minus 1 squared is plus 1. Minus 1 cubed is minus 1. Times minus 1 is plus 1. So we get to here quite quick. 9 plus 9 minus 9 is just 9. Minus 3 plus 1 is minus 2. Plus a third. I'll take my time on this. So we get 9 minus 2 plus a third is minus 1 2/3. 9 plus 1 2/3 is 10 2/3, and we're done there. Okay, integrating to find area. SQA, Higher Maths, 2019, Paper 1, Question 8. The graphs of y equals x squared plus 2x plus 3 and 2x squared plus x plus 1 are shown. They intersect at minus 1 and 2. Express the shaded area as an integral. So it's leading us through this one. Remember, to get our shaded area, it is the upper curve minus the lower curve. So just tracing this, there's my upper curve there, which is this one, and there's my lower curve there. So I do the integral between minus 1 and 2 of this minus this. So for part A, it's the integral between minus 1 and 2 of x squared plus 2x plus 3 minus 2x squared plus x plus 1 dx. Tidying that up, so minus 1 and 2. X squared minus 2x squared is minus x squared. 2x minus x is plus x. 3 minus 1 is 2 dx. So part A is done. Part B says calculate the shaded area, so work that out in other words. So for part B, our integral equals add 1 to the power, divide by the new power, plus x squared over 2 plus 2x, all between minus 1 and 2. Subbing in our numbers, we get minus a third of 2 cubed plus 2 squared over 2 plus 2 times 2. That's our first one. Take away minus a third times minus 1 cubed plus minus 1 squared over 2 plus 2 times minus 1. Okay, so then we need to work on this. So 2 2s is 4 times 2 is 8. So we get minus 8/3 for our first bracket. 2 2s is 4, divided by 2 is 2, and 2 2s is 4. So there's our first bracket. And our second bracket, minus 1 cubed is minus 1, times minus a third is just a third. Minus 1 squared is 1, so that's a half. And we've got minus 2. So we've got some fractions to deal with, and it was paper 1, so we're just going to have to keep going. Minus 8/3 plus 6 minus, I'll just times them together to get 6. 2 and 3 is 5. So we get this. I will now just take the brackets away. Minus 8/3 plus 6 minus 5/6 minus plus 2. Putting the numbers together, you get 8. And I've got minus 8/3 and minus 5/6 to deal with. That's 8. Doubling 8 is 16. So that's 16 over 6 minus 5 over 6. So that gives me 8. 16 minus 5 is minus 21 over 6. Changing that to a mixed number. 8, 6 3s is 18. And 3/6. Simplifying, 8 minus 3.5. 8 minus 3 is 5. Minus another half is 4.5. Don't worry about all that extra substitution and what you need to do. You get most of the marks for getting to the point of substituting in. Okay, so don't worry if you can't get that far. Question 4 says the graph has an equation x cubed minus 5x squared plus 2x plus 8. The total shaded area bounded by the curve and the x-axis.
we've got this area here and this area here. In the first part of the question, calculate the shaded area above the x-axis, so between -1 and 2. So for part A, we need to integrate between -1 and 2 our function x cubed minus 5x squared plus 2x plus 8 dx. And that'll give us the area. So x cubed becomes x to the power of 4 over 4 minus 5x cubed over 3 plus 2x becomes x squared divided by 2, still x squared, plus 8x, and we're doing that between the limits of -1 and 2. So we need to substitute 2 in, take away, then substitute -1 in. So for our first bracket, we've got 2 to the power of 4 over 4 minus 5, 2 cubed over 3 plus 2 squared plus 8 times 2. Take away our second bracket, -1 to the power of 4 over 4 minus 5 minus 1 cubed over 3 plus -1 squared plus 8 times -1. So let's work out each bracket separately, and I'm going to keep it as fractions so that our answers as nice as possible. I'm just using my calculator to get those fractions. So our first one, we have got 4 for the first term minus 13 thirds plus 4 plus 16, and we're taking away a quarter plus 5 thirds, because it's minus times a minus, plus 1, take away 8. So for the first bracket, we would get 10 and 2 thirds, minus the second bracket, which is minus 5 and a 12. So adding them together, you would get 15 and 3/4 units squared as our area. Part B then says, hence calculate the total shaded area. So we've already got this bit, so we just now need to work out the integral between 2 and 4. And just a reminder, when you're wanting to work out an area when it's below as well, you would do this one, take away this one, and that will give you your total area. So for part B, we've got our integral already between -1 and 2 of x cubed minus 5x squared plus 2x plus 8. And we're going to take away the integral between 2 and 4 of the same thing, x cubed minus 5x squared plus 2x plus 8 dx. Just put that bit in brackets just to separate it out. And I'm going to do that bit first. I already know the answer to this bit. Let's just write that down. So that gives us 15 3/4 minus, let's just start integrating now. So we already know the answer to that, so there's no extra work required. It's 1/4 x to the 4 minus 5 over 3x cubed plus x squared plus 8x, and that's between 2 and 4. So keeping that 15 3/4 just floating about, minus, let's just use big brackets. Let's substitute our 4 in to start with. So we end up with 4 to the power of 4 over 4 minus 5 times 4 cubed over 3 plus 4 squared plus 8 times 4. So that's our first limit. Take away our second limit, which in this case is 2, so it's 1/4, 2 to the power of 4 minus 5, 2 cubed over 3 plus 2 squared plus 8 times 2. 15 3/4 minus the first bracket, it's 64 minus 106 2/3 plus 16 plus 32. That's this bracket here. In this bracket, we already know the answer to because we did it in part A, so we might as well just write down the answer. That was 10 2/3. So take away 10 2/3. (15 3/4) minus first part of the bracket gives you 5 1/3 minus 10 2/3. So that means our area is 15 3/4 minus the answer to this, minus 5 1/3. Minus, minus, so we're adding them together. So 15 3/4 plus 5 1/3 gives us a final answer of 21 1/12 units squared. Hi, Maths 2023, paper 1, question 11. Part A, integrate between pi over 2 and pi, 5 sin x minus 3 cos x. And then part B is draw a picture. So part A, the integral between pi over 2 and pi of 5 sin x minus 3 cos x dx. I'll stick to radians for this because radians is integration only works in radians, it doesn't work in degrees anyway. So check in front of the exam paper and it will tell you that sine integrates to minus cos. So we've got minus 5 cos x, and then cos integrates to sine, so minus 3 sin x, and our limits are between pi over 2 and pi, so we're summing our limits. So we get minus 5 cos pi minus 3 sin pi, take away minus 5 cos pi over 2 minus 3 sin pi over 2. Now, although I'm doing it in radians, I like to think in degrees, so I know that pi is 180. The cos of 180 is just minus 1. So that's minus 5 times minus 1. And the sine of 180 is 0. So that's minus 0. And then take away, pi over 2 is 90. The cos of 90 is 0. So that is 0 for the first term. And the sine of 90 is 1. So that is minus 3 times 1. So that gives me minus 5 minus 1 times minus 1 is just 5 for the first bracket. Minus 3 on the second bracket, but times another minus outside. So plus 3. Which gives me a grand total of 8 square units, because we've not got any units. So you'll probably not need this, but just to be on the safe side, but 8 is our answer. On the diagram of your answer book, shade the area represented by the integral in A. So the integral is between pi over 2 and pi. There's pi, so we can mark pi. And pi over 2, 90. So there's pi over 2. So it's a bit between these. So we can just draw some vertical lines and shade in this bit and shade in this bit. It's the integral between them, so it's the area between the curves at that point. It's just asking if you understand if that means that. Just check your areas. You've got 5 sin x on the top, minus 3 cos x, which is exactly what we were integrating. So it's the integral between these two curves, between these 2 points. So we're done there.
It's going to be Higher Maths 2023, paper 2, question 8. The diagram shows the curve x cubed minus 2x squared minus 4x plus 1, and the line y equals x minus 5. And with the intersect at minus 2 and 1, calculate the shaded area. Now, you can't see the shaded area in this question because of the way it's scanned, but it was the bit in between here. So the shaded area is between our limits of minus 2 and 1. So integral, because it's an area, between minus 2 and 1 of upper minus lower. So our upper is the curve, x cubed minus 2x squared minus 4x plus 1. Take away our lower, which is the curve, the line, sorry, x minus 5 dx. So that becomes the integral of minus 2 to 1 of x cubed minus 2x squared minus 4x minus x is minus 5x. and 1 minus minus 5 is plus 6 dx. So we're integrating, so we add 1 to the power, divide by the new power. So that gives us x to the 4 over 4 minus 2x cubed over 3 minus 5x squared over 2 plus 6x, and that's between minus 2 and 1. So now we need to substitute. So substituting our limits, our first limit is 1, so it's 1 to the 4 over 4 minus 2 times 1 cubed over 3 minus 5 times 1 squared over 2 plus 6 times 1. Quickly run out of space, so I'll put my minus here and then put in minus 2 in. We get minus 2 to the power of 4 over 4 minus 2 times minus 2 cubed over 3 minus 5 times minus 2 squared over 2 plus 6 times minus 2. Now usually at this point, depending on the mark scheme, you're only going to get 1 mark, usually more, after you've substituted. So if you get really stuck here, just move on. But let's just try and get it, okay? So that gives us, being very careful, first term, 1 4 over 4 is just a quarter for the first bracket. 1 cubed is 1, so I get minus 2 thirds. 1 squared is 1, so I get minus 5 halves. And plus 6. I'm not going to bother trying to add these fractions, I'm going to use a calculator. Minus 2 to the 4, 2 2s are 4 times 2 is 8 times 2 is 16, so I get 16 over 4, which is 4. 2 2s are 4 times 2 is 8 times 2 is 16, so I get minus 16 plus 16, sorry, over 3, because it's minus times a minus. 2 2s are 4, 4 5s are 20, so minus 20 over 5, minus 20 over 2, sorry, or you could have written 10, and then 6 2s are 12. So now it's calculator time if you've not got me already. Okay, calculator, fraction, brackets and fractions. So you open a bracket, use your fraction button, 1 quarter, minus, make sure you use the arrow if you have to, minus 2 thirds, minus 5 halves, plus 6, so there's my first bracket. And then our second bracket, I've got minus 4 plus 16 over 3, arrow, minus 20 over 2, arrow, minus 12, close the bracket, press equals. I'm getting 15.75, so I'm going to write 15.75 square units. 15.75 is a fine answer. You can leave it as a decimal, that's completely fine. If you'd done it without a calculator, or your calculator gives you answers in fractions, you may have got an answer over 15 and 3/4. So you could have got 15 and 3/4. Or 15 fours is 60 plus 3 is 63. 63 over 4 would be another answer. Integrating a trig function, which also ties in with the chain rule. So we've got SQA Higher Maths 2015, paper 2, question 7. Part A, find the integral of 3 cos 2x add 1. So we've got the integral of 3 cos 2x plus 1 dx. You don't need to have a headache here. Check the start of the exam paper, it tells you if you integrate cos, you get sine. So I know what that's going to give me sine. So we've got 3 sine 2x. The 1 integrates to x, but we'll get there in a minute because you need to be careful here. This is not cos x, it's cos 2x, so the chain rule applies. So you differentiate 2x to get 2, and you then divide by it. So it's divided by 2. And now I can integrate the 1, so it's plus x, and then I've got a plus c on the end. So just tidying that up a little bit, I could write that as 3 over 2 sine 2x plus x plus c. And we're done there. Part B says show that 3 cos 2x add 1 equals 4 cos squared x minus 2 sine squared x. So it's a trigonometric question. We have to use our cos 2x expansion from the start of the exam paper. So part B, 3 cos 2x plus 1. I'm going to try and make that look like the right hand side. So cos 2x, I'm going to expand to cos squared x minus sine squared x. And that's still plus 1. So that's 3 cos squared x minus 3 sine squared x plus 1. Let's see what we're trying to make it look like. Well, there's no actual 1 in the question, so we're going to change 1 in a funny way, because 1 is sine squared x plus cos squared x. So taking that 1 out, we get 3 cos squared x minus 3 sine squared x plus sine squared x plus cos squared x. 3 cos squared x plus cos squared x is 4 cos squared x, and minus 3 plus 1 is minus 2 sine squared x. And we should be done there. Okay, part C, integrate sine squared x minus 2 cos squared x dx. We're going to use our result that we've just found out, because that looks very similar to this result. So let's have a look at what this result was. It was 3 cos 2x add 1. So as an aside, 3 cos 2x plus 1 was equal to 4 cos squared x minus 2 sine squared x. If I divide this by 2 then, I would get 2 cos squared x minus sine squared x. So let's just do that to start with, just so you can see what's happening. Divide by 2 on both sides. We would get 3 over 2 cos 2x minus plus a half equals 2 cos squared x minus sine squared x. But this is the opposite signs on here. So if I then divide through by minus 1, or move everything to the left hand side, I suppose, there's another way to think of it. Then you get minus 3 over 2 cos 2x minus a half equals minus cos squared x minus 2 cos squared x plus sine squared x, which is exactly what I'm trying to integrate. So if I can integrate my left hand side. So my integral becomes the integral of minus 3 over 2 cos 2x minus a half dx. So that equals minus 3 over 2 cos goes to sine, so sine 2x. And you need to differentiate the 2x to get 2 and divide by 2. So I'm dividing the whole thing by 2. A half minus a half goes to minus a half x, and we've got plus c. Dividing a fraction by a number means I can just times the denominators. So we get minus 3 sine 2x over 4 minus a half of x plus c. And we're done there. A trig function with the chain rule. SQA Higher Maths 2016 paper 1 question 5. Integrate 8 cos 4x add 1 dx. Cos goes to sine, check the start of exam paper, so that equals 8 sine, the whole function 4x plus 1. But then I need to differentiate 4x plus 1, well that's 4, and divide by that. So divided by 4, and don't forget your plus c. 8 divided by 4 is 2, so we get 2 sine 4x plus 1 plus c. And we're done there. Okay, integrating a trig function again with a chain rule. We've got Higher Maths 2019 paper 1 question 11. Evaluate the integral between 0 and pi over 9 of cos 3x minus pi over 6 dx. Exact value question as well, because it's non-calculator. So let's start integrating. That becomes cos goes to sine, remember. We're looking at the start of the exam paper. The whole function 3x minus pi over 6. But then we need to differentiate this. Well, that's just a number, so that's nothing. That becomes 3. So divide by 3. And that is the integral between 0 and pi over 9. So there's our first step. Now we need to just substitute in. So that gives us a third of sine, well, 3 times pi over 9, we'll just write, minus pi over 6. That's our first one. Take away our second one, subbing 0 in, so that's a third, sine 3 times 0 minus pi over 6. Okay, so we can now, we'll just tidy that up, put an extra bracket on. We can now just evaluate that. So that gives me 1/3. If I take my first one, sine 3 pi over 9. So let's just do this. 3 pi over 9 is pi over 3. So I've got pi over 3. And then our pi over 6, we can think of that as minus pi over 6. Take away 1/3 of sine. And then 3 nothings is nothing, so it's just minus pi over 6. So that gives me 1/3 of the sine of, well, pi over 3 is 2 pi over 6, minus pi over 6 is pi over 6. So we've just got pi over 6 now. Take away 1/3 of the sine of minus pi over 6. So we're going to have to work out what the sine of pi over 6 is. So if you're thinking in degrees, pi over 6 is the same as 180 over 6, which is 30 degrees. So exact value triangles is how I always think of this. So if I got myself a triangle with 2 on this side, 1 on that side, then by Pythagoras, 2 2s is 4, minus 1 is 3, that is root 3. Now that was 60, so that one's 30. The sine of 30 degrees is equal to a half. You might have just memorized that yourself. If you think of a sine graph or a cast diagram, you can see that minus 30 would be about here. It's obviously minus a half for the sine of minus 30 degrees. 1/3 of the sine of 30, so 1/3 times a half, minus 1/3 times minus a half. So 1/3 times a half is a sixth. 1/3 times minus a half is minus a sixth. So plus another sixth because of minus times a minus. That is 2/6. That is 1/3. And we're done there. Okay, integrating with the chain rule, not a trig function. This one, 2017, paper 1, question 13. Integrate this function. So we need to get it ready to integrate first. So that becomes the integral of 5 minus 4x to the minus a half dx. It's telling you obviously that x can't be less than 5 over 4 because this would be not valid. Now let's integrate that. So we add 1 to the power. So we get 5 minus 4x to the power of a half. We divide by the new power. So we divide by a half. But we also divide by the function differentiated, so times minus 4 on the bottom as well. And we've also got plus c, of course. So that gives me 5 minus 4x to the half. A half times minus 4, well, minus 4 divided by 2 is minus 2. Plus c, tidying that up, put my minus on top. That gives me minus a half of 5 minus 4x to the half plus c. And you would be fine just stopping there. Getting with chain rule, SQA High Maths 2018, paper 1, question 14. Find the integral between 9 and minus 4 of this function. Going to have to get it ready to differentiate first. So we've got between minus 4 and 9, 1 over. So it's the cube root, so that's to the power of a third, but it's squared, so it's to the power of 2/3. So it's 2x plus 9 to the power of 2/3 dx, which equals the integral between minus 4 and 9, taking it up to the top, 2x plus 9 to the minus 2/3 dx. And now we can integrate it. So we add 1 to the power and divide by the new power, so being very careful, we've got 2x plus 9. Add 1 is a third. Divide by our new power, so divide by a third, but also divide by this differentiated, which is 2. So I can say times 2 on the top bottom as well, and that is between minus 4 and 9, which I'll substitute in when I'm ready. Now this is a non-calculator question, so I'm going to have to put it back into root form as well. So that gives me 2x plus 9 cube root. So I can just write the cube root of 2x plus 9. 2 times a third is 2/3. And that's between minus 4 and 9. Almost done. Dividing by a fraction means we can times it by the reciprocal, flip it upside down in other words. So we get 3 times the cube root of 2x plus 9 over 2 between minus 4 and 9. And now I'm ready to substitute my numbers in. So substitute 9 in, take away, substitute minus 4 in. So subbing in my numbers, get 3 times the cube root of 2 times 9 plus 9 all over 2. I'll just put that in big brackets. Minus 3 times the cube root of 2 times minus 4 plus 9. I'll just make that clear that that's separate all over 2. And now we can work some of that out. So that's 3 times the cube root of 2 9s is 18, 18 and 9 is 27 over 2, minus 3 times the cube root of 2 times minus 4 is minus 8, add 9 is 1 all over 2, and that's handy because that now simplifies quite easily. The cube root of 27, 3 times 3 is 9 times 3 is 27, so this just gives me 3 times 3 over 2 minus cube root of 1 is 1, 3 times 1 over 2, that equals 9 over 2 minus 3 over 2, which equals 6 over 2, which equals 3. And we're done there. SQA Higher Maths 2022, Paper 1, Question 6. Integrate between minus 5 and 2, 10 minus 3x to the power of minus a half dx. Okay, let's start working on this. So we've got the integral of minus 5 and 2 of 10 minus 3x to the power of minus a half dx. Well, we can start to integrate this by adding 1 to the power. So we've got 10 minus 3x to the power of a half. We then need to divide by the bit inside the brackets differentiated. So inside the brackets is 10 minus 3x. If we differentiate that, you get minus 3. So we need to divide by minus 3, or in other words, that's the same as times it by minus a third. You get your first mark for just starting to do that, and you get your second mark for showing anywhere that you are going to be dividing by minus 3 or timesing by minus a third. So there's your first 2 marks there. And then we need to process our limits. So let's tidy this up a little bit before we get to that. So we get 10 minus 3x to the power of a half. Dividing by a half is the same as timesing by 2. We've got a minus because of the timesing by minus a third, divided by 3. Now, our limits are 2 and minus 5. So we've got minus 2, 10 times minus 3 times 2 to the power of a half divided by 3. There's our first limit, and that is minus 2, 10 minus 3 times minus 5 to the power of a half divided by 3. So there's our 2 limits because it's between minus 5 and 2. So your third mark is actually coming in at this point. For substituting in 2 and minus 5 and putting the minus in between, you are getting that mark. So there's your third mark there. And then your final mark is for actually working that out. So let's work that out now. Just being very careful. So we've got minus 2. 10 minus 6 is 4. So it's times the square root of 4, because the power of a half is square rooting, divided by 3, and that's minus And then we've got minus 2 again. 10 minus 3 times minus 5. That's minus 3 times minus 5 is 15. So that's 10 add 15, which is 25. So it's times the square root of 25 over 3. Working out that, we get minus 2 times 2, which is minus 4 thirds, minus 2 times 5, which is minus 10 thirds. Minus 4 plus 10 is 6, so that's 6 thirds, which is equal to 2 in the end. So if you can get down to getting 2, there's your final mark there for working that out. Okay, let's go through some key points of where you could go wrong in this question. If you differentiated and didn't integrate, unfortunately you get no marks at all, even if you're substituting numbers in. There's no way to get any marks for that. If you start to integrate individual terms, if we go back to the standard, the actual question, if you're trying to integrate, say, the 10 to get like 10x, and then the minus 3x to get something like minus 3 over 2x, you're just doing it inside the bracket, or you're trying to expand the bracket, you can't get any more marks after that as well, because it's just invalid, it doesn't work. For mark 4 down here, it's only available for non-integer power. So in other words, if your power here, I've got a half as the correct answer. If you'd use squared or cubed or 4, that we wouldn't get a mark because we're checking if you can do the third part as well. SQA Higher Maths 2023 Paper 2, Question 3. Integrate 7 cos 4x plus pi over 3 dx. So we're going to use the chain rule here because we've got an inner function. So integrate cos, well, cos goes to sine, using the start of the exam paper. So that integral straight away becomes 7 sine 4x plus pi over 3. But then we need to divide by the inner function differentiated. So differentiate 4x, you get 4. Pi over 3 is nothing. So it's just 4. And then we've got plus c, remember? Don't forget your plus c. We could leave it like that, but I'm just going to tidy that up slightly by taking the fraction outside. So we get 4x plus pi over 3 plus c. And we're done there. Higher Maths 2015, Paper 1, Question 12. Some unusual integration questions or some harder ones. So the diagram shows the graph of y equals a cos bx. The shaded area is a half. So we know that this is a half. What is the value between 0 and 3 pi over 4? This is checking if you understand graphs and also understand the symmetry in a sine graph. So if we know that that's a half, if I draw a little line here, we know that that's also a half, and therefore that bit must also be a half. But it would be minus a half and minus a half because we're below the x-axis. So that means that our integral between 0 and 3 pi over 4 of a cos bx just simply must equal, well, we know that's a half as well, just to be clear, it must equal 1/2 minus a half minus a half. So a half minus a half is 0, minus another half is minus a half square units. And that's it, we're done there.
The chain rule. SQA Higher Maths 2016, Paper 2, Question 10. Given it y equals x squared plus 7.5, find the y by the x. And then part B, hence find the integral of this function, which we'll use our answer to part A to do. So part A, the y by the x is equal to, take the half down to the front, x squared plus 7, take 1 off the power, minus a half, and then we differentiate the bit inside the brackets, which is x squared, so that becomes 2x. So that equals 2x divided by 2 is just x, so x bracket x squared plus 7 to the minus a half. And then try to make it look a bit like our part B, that's x over x squared plus 7 to the half, which is equal to x over the square root of x squared plus 7. Part B says integrate 4x over square root of x squared plus 7, which is very similar. So if I do part B, integrate 4x over the square root of x squared plus 7 dx, Well, if I just take that 4 out, I get the integral of x over the square root of x squared plus 7 dx, which I already know is exactly the same as what I found out up here, my differential. This integrated is exactly that. So I can just write the integral as x squared plus 7 to the half. Simple as that. So that means I've got my answer is 4 times x squared plus 7 to the power of a half. Or, let's make that neater, x squared plus 7 to the half. I've forgot my plus c, so there we are, plus c, and we're done there. We move on to what I would say is unusual differentiation questions. The first one we're going to look at, just stuff that doesn't come up as often, is this one. A quadratic function is defined on a set of real numbers. This was 2017, paper 1, question 15. Diagram 1 shows the graph of y equals f of x with the turning point at 2, 3. And diagram 2 over here shows the graph of h of x, and the turning point is now 7, 6. Okay, let's see what it's asking us to do. Part A. Given that h of x is f of x plus a plus b, write down the values of a and b. So in other words, it's a graph transformation question for part A. So let's have a look to see what's happened. If we look at this point 3, well, let's just look at the turning point, 2, 3. It's clearly moved along to become 7. 2's become 7. It's moved to the right by 5. So if it's moved to the right, then a must be negative. So a is negative 5 because it's moved to the right by 5. And then our b, well, plus b on the end means it's moved. The whole thing's moved up by some number. We started at 3 and we've ended up at 6. 3 plus 3 is 6. So b is simply the number 3. And we're done there. So part B says it is known that the integral between 1 and 3 of f of x is 4. What is the value between 8 and 6 of h of x? Well, an integral means an area. So we know that the area under this bit here is 4. So that means over on this graph, since it's just moved up, this whole area here is also 4. And leaving the extra bit between 6 and 8 is just a rectangle. That is 2 along. And that must be 3 because the graph's moved up by 3. 2 times 3 equals 6. So our integral between 8 and 6 of h of x is just 6 plus 4, which equals 10. And we're done there. Part C says, given that f-1 equals 6, what's h-8? f-1 equals 6. Let's just use a different colour pen now. That means that the gradient of the tangent at this point here equals 6. And it's asking us, what is the gradient of the tangent at 8? Well, at 8 on h of x, 8 is this bit here. Now that's, if we imagine looking at this graph instead, that would be this point here. It's a mirror of this, so it's sloping down the way. So it's just minus 6, because it's just the other side of the graph. So h dash of 8 equals minus 6, and we're done there. Trigonometric Equations, SQA Higher Maths, 2019, paper 1, question 15. Solve the equation sin 2x plus 6 cos x equals 0. And then solve a new equation for part B. So for part A, sin 2x plus 6 cos x, a sin and a cos, they're different from each other. So I will span the sin 2x to give me 2 sin x cos x. And this time we're working in degrees, plus 6 cos x equals 0. So although we've got a sin and a cos, there is a common factor, so I can factorise. So the common factor is cos x, but it's also got a number attached. 2 is also a common factor, so 2 cos x goes outside. That gives me sin x in the bracket here. And 2 cos x times 3 is 6 cos x, so plus 3 equals 0. And then we've just got two equations to solve. We can say 2 cos x equals 0, or we can say sin x plus 3 equals 0. This one gives me sin x is equal to minus 3, which has no solutions, because the maximum and minimum of sin x is 1 and minus 1. So this one, 2 cos x equals 0, means that cos x also must be 0. You should know that cos x is equal to 0 at 90 degrees. If you don't, there's a little graph for you just to prove it. 1 and minus 1, it goes along 90, then 180, then 270.
So we can immediately say that x equals 90 degrees. You could also say it's 270 straight away, but if you didn't know it was 270, cast diagram would give you the other one because cos is positive. So 360 minus 90 would give you your 270 as well. And we're done there for part A. Part B says, hence solve sine 4x plus 6 cos 2x equals 0. Part B, sine 4x plus 6 cos 2x equals 0. So part A was sine 2x plus 6 cos x. So the numbers in front haven't changed, so it's not a multiple. However, the angles have just doubled, so the frequency's just doubled. So that means that our answers to part A was when x equals 90 and 270. So now it's just 2x equals 90 and 270. There's no real extra work to do. So for part B, I can just say straight away 2x degrees equals 90 degrees and 270 degrees. But I want to solve it between 0 and 360. So there's going to be more solutions than that because I'm going to divide my answers by 2. So I just add 360 to everything. I'll just write that here, plus 360. Then it's going to give me 450 degrees. And it's also going to give me 630 degrees. And then I can just divide each of them by 2 to get 45 degrees, to get 135 degrees, to get 225 degrees. And the final one is 315 degrees. And we're done there.